All right, let's jump right in. You've probably heard two completely different stories about AI, right? On one side, it's this brilliant student soaking up knowledge like a sponge. But on the other, it's a super confident liar, just making stuff up. So how can it be both? Well, that's the paradox we're going to dig into today.
It all kicks off with a pretty simple question, really. Someone asked ChatGPT, hey, what's the oldest photo of a cat? And the AI comes back with this incredibly specific answer. It talks about a daguerreotype, gives a title, cat with blue ribbon, names the photographer, even nails down the year to 1840. I mean, it sounds totally legit, right? So confident.
Yeah, there's just one tiny problem. That photo, cat with blue ribbon, it doesn't exist. It never did. It was completely made up. And that right there is the huge question we're trying to answer. Why are these incredibly smart systems so good at confidently, well, lying?
So, to get to the bottom of this, we first have to really understand this confident liar side of AI. What is actually going on under the hood when a model just invents a fact out of thin air?
Okay, so the fancy term for this is AI hallucination. And all it means is that the AI creates something that totally conflicts with the data it was trained on, or something that just can't be backed up by facts in the real world. It's not just getting something wrong, it's presenting a pure fabrication as if it's the gospel truth.
Right, so we know these AIs hallucinate. The next logical question is, how bad is it? Like, how do you even measure that? How can we build a kind of AI lie detector to catch them in the act?
Well, that's exactly what a group of researchers set out to do with a study called HalluEval. You can think of it as a massive purpose-built lie detector test for large language models. Its whole job is to figure out just how often these models are making things up.
And the way they did it is just brilliant. It's this clever two-step dance. First, they actually used ChatGPT to create thousands of these plausible-sounding but totally false statements. But then, and this is the genius part, they used ChatGPT again to sift through all those lies and pick out the most convincing ones. They basically weaponized the AI against itself to create the toughest test possible.
So the big question is, what did they find? The results were pretty eye-opening. The HalluEval study discovered that almost 1 out of every 5 responses from ChatGPT to a regular user query had some kind of hallucination in it. Think about that. That's 19.5% of the time.
Okay, so that naturally leads to the next question, right? We know the models are good at making these lies, but are they any good at spotting them? In their own writing or maybe in stuff from other AIs?
And this is where it gets even more worrying. When they were tested on recognizing these hallucinations, the scores were, well, they weren't great. In a Q&A task, ChatGPT was only right about 62.6% of the time. Claude 2 was a little better, sure, but look at those numbers. They're dangerously close to just flipping a coin, which is 50-50. They're almost as likely to miss a lie as they are to catch it. So at this point, you're probably thinking these models are just fundamentally broken, right? But here's where the whole story flips on its head. How can something so full of errors also be so incredibly smart? Well, it all has to do with this wild idea of learning from weak teachers. And this is the paradox at the very heart of AI. I mean, if the internet is packed with flawed data, and the models themselves make stuff up and are bad at catching their own mistakes, then how in the world do they get so smart? How does the student become so much more brilliant than its very flawed teacher? The answer is a fascinating concept called weak to strong generalization. And the idea is pretty simple, actually. You take a more powerful model, that's our strong student, and you train it on the output of a less powerful model, or even just some basic rules. That's the weak teacher. And what happens is, the student doesn't just learn what the teacher knows, it actually becomes smarter than the teacher.
And this all works because of two really surprising things that happen. First, something called pseudo-label correction. Basically, the student model actually learns to fix the teacher's mistakes. Its performance ends up being better than the quality of the data it was even trained on. And second, coverage expansion. The student learns to handle totally new situations that the teacher never ever saw.
But how? I mean, what's the actual mechanism that lets this happen? It all boils down to a really cool idea you can think of as the good neighbor theory.
This quote from the research really nails it. It says that the strong model can't just memorize the weak teacher's mistakes without making its own overall understanding worse. See, a powerful model is always looking for the simplest, most consistent patterns. And a single mistake? That's just noise. It's an inconsistency. Trying to fit that one wrong data point would actually mess up the whole beautiful pattern it's trying to learn.
Let's break that down, because it's super important. Imagine you have one data point that's labeled wrong. That's our bad point. But all around it, it's probably surrounded by thousands of very similar points that are labeled correctly. Those are the good neighbors. Now, a powerful model is trying to find a simple, consistent rule that explains everything. And to be right about all those thousands of good neighbors, it's forced to just ignore the one bad label. It's easier to treat it as a fluke. So, in its effort to be as accurate as possible overall, it basically ends up correcting the teacher's mistake.
Okay, so let's put it all together now. We've got the confident liar on one side and the brilliant, self-correcting student on the other.
You know, the biggest takeaway from all of this is that we absolutely cannot think of AI as some perfect, all-knowing oracle. It's just not. It's a walking paradox. It's deeply flawed and, at the same time, capable of a brilliance that allows it to overcome those flaws.
So let's just quickly run through what we've learned. We know AI models hallucinate. They confidently make things up. We also know they're shockingly bad at spotting those fabrications, even their own. But we also discovered they have this incredible ability to learn from flawed, messy data. This weak to strong learning lets them fix their teachers' mistakes and grow even smarter. Understanding this duality, this flawed yet brilliant nature, that's the absolute key to using AI safely and effectively.
And that leaves us with one last really big question to chew on. These models, they're learning from our world, our data, and our world is messy and flawed. So as this brilliant student keeps learning from us, the weak teacher, the real challenge becomes, how do we guide it? How do we push it toward not just reflecting our flawed reality, but aiming for a better, more honest version of the truth?